Tools like Claude Code and OpenAI Codex have made it easier than ever before for anyone to build software, but almost nobody shows you how to actually deploy that software to production. So in this video, I'm going to show you step-by-step how to deploy an AI system to Google Cloud, but using OpenAI Codex to do most of the work for us. If you can't deploy and operate software as a developer, you're going to be extremely limited, but if you can, you'll be able to build the kind of systems that businesses can trust and pay real money for. If you're new to the channel, my name's Owen. I've been a software engineer for the past 20 years, and I've owned and operated systems handling billions of requests per week. Everything I show you today is based on the same setup that I use for projects within my own business. All of the resources are going to be linked for free in the description below, so let's get into it. So a quick disclaimer, just before we get into the demo, there are obviously real risks of letting AI agents loose on your production infrastructure. You've probably heard horror stories about AI agents wiping out production databases, and those risks are very real. But what we're talking about today is more about using AI agents in the early stages of a pre-production environment where you're just provisioning your project, you're trying to get something up and running, or you're trying to debug an issue within your development stack, basically. And so once you get into production, you can obviously change your processes to put more guardrails in place, but using AI agents in the early phases of building out your infrastructure is so incredibly useful. So when it comes to deploying software, you basically have three options, and all of them have some kind of trade-off. The first option is to use some kind of virtual private server. You can rent a Linux server from DigitalOcean or Hetzner. You can put your application on it. This is very simple, cheap and easy to get started with. But the moment you start scaling or you have multiple servers, you end up doing all of this kind of work yourself that you probably don't want to be doing, setting up your own logging and monitoring and things like that, configuring your own backups, dealing with load balancing setups that you have to manage manually. I don't want to be doing any of that work anymore personally. The other option is something like a managed platform as a service offering like Vercel, Railway, or Render. I really love the developer experience here. The idea here is you just push your code. You don't have to deal with any of the complexity that comes with cloud infrastructure. They just run your service for you. But the downside here is you don't really get much control. They often lack services you need for AI systems. And you're also going to probably want to use a cloud provider anyway to get your AI inference. And the reason for that is that the cloud providers have much better security controls, SLAs. Cloud providers give you everything you want, but they can be quite difficult and confusing when you're getting started. So this is where AI agents can really help us because they take all of the bad things about cloud and it just makes all of that so much easier. If you get stuck on a permissions error or something goes wrong, an AI agent can connect to your infrastructure. They can do some research and figure out what needs to be done. They can also audit your service as well. So I think these agents can make your infrastructure more secure. So whenever you've got a bad or misconfigured permission setup, if there's something wrong in your infrastructure or something isn't configured correctly, AI agents are really good at identifying where you've got problems in your system. So the application we're going to be building today is a fairly typical AI system. This is a customer support question and answer system, the very typical kind of RAG system you would see many companies adopting. The idea here is that when you have customers and they have questions, rather than having humans answer those questions for the customer, we're going to have an AI do that, which gives the customer an instant answer. Typically, I would use Python for the backend API. We would use Next.js and TypeScript for a front end. I tend to use Postgres for pretty much everything. And we also need some kind of AI from somewhere. So we're using Vertex AI from Google, which gives us access to the Anthropic Claude model. Okay, so the first thing I'm going to do is basically start the application locally that we're going to be deploying. So I'm just going to show you how this works. Okay, so Codex has now started up the application. Let's take a quick look at it. So this is the application we're going to be deploying today. I built this quickly for the demo. So the first thing we're going to want to do is get Vertex AI configured because we need to have some kind of AI inference to basically run and answer the questions. So the first thing we're going to do is go to Agent Platform to find the models. And then we're going to look for the Anthropic model. The latest one is Claude 4.7. So if we scroll down here, we can see Anthropic as a partner and you can see the different models you have available on Vertex AI. You get a whole bunch of models that you can get access to. We're going to be using Claude because it's my preference. And you'll see here we need to actually enable this model before we start using it. This is actually the only manual step we're going to be doing here because you need to sign an agreement with Anthropic when you enable this for the first time. And so I'm just going to go through that and get this set up. All right, so now we have Anthropic set up. So we have Claude Opus 4.7, which we can now use. If you check out this line here, you can see how to actually use this with Vertex AI. You can run a smoke test if you want, which might be a good thing to kind of quickly test out to make sure we can invoke Anthropic Vertex. So let's do that first. So I now have Vertex AI configured, and I want you to run a quick smoke test to make sure that we can invoke the endpoint and everything is working correctly. I'm going to give you some sample code. I want you to go and invoke the endpoint and make sure everything is working. So just to show you quickly, this is the application we're going to be deploying today. It's a basic customer support application. We have a Python backend, and then we have a JavaScript Next.js front end. So the way this application works, we can answer questions that customers have. We're going to be using static documents here that we load into the system, and we're going to be using agentic RAG. So the idea here is that these documents are stored in a database, and we have some kind of index which an AI agent can reference. So when a customer asks a question about accounts and subscriptions, the AI agent is then going to know which document to load from the database. It's going to read that document and then answer the question. So this is a very simple form of RAG. It's using AI agents to find the right document, essentially. So we're not using vector search here. It's a pretty simple setup. So the first thing I'm doing is asking Codex to run a quick smoke test. So I took the sample code from GCP, I gave it to Codex, and I asked it to configure everything. So make sure the local project is configured correctly so that we can run the application and invoke the Vertex AI endpoint. This is just a quick sanity check just before we start deploying anything. We want to make sure that everything works correctly locally. All right, so now the project is set up. We're using the correct project. We've enabled Vertex AI. We've set our configuration, etc. And we're able to run a smoke test. So we were basically able to invoke Vertex AI on Google's cloud platform. So now we're getting our AI inference directly from Google. So the thing we're going to do next is come up with a deployment plan. So can you help me figure out how to deploy this application to Google Cloud? I want to use Google Cloud Run for the UI and the API. I want to use Vertex AI for the inference. And I want to have some scheduled jobs that will ingest any changes to the documents that we make. I want to have a scheduled job that will ingest those documents. We can host the documents inside a cloud storage bucket. Come up with a plan that I can review and we can discuss. So Codex has come up with a really detailed plan for deploying our application, and we just want to review this plan and make sure it makes sense. So basically what happened is I asked Codex to figure out how to deploy this application. I gave it some guidance on the services I want to use and how I like to deploy stuff. You can see here that's come up with a plan. So we're going to be using Cloud Run for our web services. We're going to be using Vertex AI for our inference. We're going to be using Cloud SQL Postgres. So I always use PostgreSQL for a database. And then we have some scheduled jobs here as well, which run on Cloud Run as well. These are like periodic jobs that you can run every so often if you want to run jobs every hour that do things like data ingest and things like that. So we've got all of the key decisions. I'm just going to review the plan and make sure it makes sense. So phase one is to create the basic resources. So we're going to use the Europe West 1 region, which is what I want to use because I'm based in Europe. We want to use the global Vertex AI region, which is how I've got it set up in terms of my rate limits. So that is fine. Everything else looks good. And you can see here we're creating a new database instance. We're going to create a Google Cloud Storage bucket, and we're going to store our secrets in this secret service. So you can see here we need to enable a bunch of APIs. So by default, when you start with Google Cloud, certain APIs are not available. So if I try and use any of these APIs, I won't be able to until I enable them. So that's one of the first things we need to do. So in phase two, we're looking at identity and access management. This stuff is the really tricky bit that gets confusing. So this is where AI can really help you. So we're creating distinct roles, one role for the SQL client and one role for the AI platform user. We're basically deciding on how to configure the permissions. All of this looks good to me. We're going to then go on to phase three, which is where we build the images. So we're going to build and push our container images. We're going to containerize our current applications, push them to Google's cloud, and then it's going to run everything for us. So you can see here that Codex is guiding us through all of the deployment process. Everything we need to do is kind of mapped out here. Obviously, your job now is just to review the plan and make sure everything makes sense. So the way I'm going to do this is track all of the work we need to do in linear. This might be a little bit of overkill here, but as you're working through a long multi-step plan, I find it really helpful to track the work in a series of tickets. That makes it very easy to see where we are in the process, not get confused and not get lost, especially if this setup takes multiple hours or multiple days. You don't want to be trying to remember things from markdown files. So the next thing we're going to do is use Codex to create all of the tickets we need to deploy the application. So what I've done now is I've asked Codex to break this work down into a number of tickets. we're going to push those tickets into Linear. And so the reason here is that this work could run for maybe an hour or two. And so rather than get confused about where we are, I'm going to break this down into a number of smaller tasks that can be implemented one by one. So we're going to start off by provisioning the basic infrastructure, getting all of the APIs enabled, and then we're going to work through it logically and sequentially so that we have everything set up in the right order and we don't get confused about where we are in the process. So I have Linear connected via an MCP server. You don't have to do this. You could save the plan in a markdown file and just work off the files locally. But I've always liked to use this approach to keep things organized and to keep sane when we're working on long-running tasks. So what you can see here now is that the Codex application is creating all of the tickets we need to start deploying our application. So we're going to work through these step by step. You can see here, if you click on one of these tickets, we have a goal for what we need to do. And then we have a proposed approach. And then we have some acceptance criteria here below and some ways to verify this work. I'm using a skill that I've built. I'll link it in the description below so that the tickets always contain just the right information needed for an AI agent to execute the work. If you click over here in Linear, we're going to go to a board view and then we can see all of the work. So we're going to make sure that we can see all of the empty columns so that we can see everything step by step. So this is the pipeline. We're going to start with the first task, move it into to do or in progress, and then work on that task all the way through until it's done. And then we're going to go through all of the tickets just like that. All right, so this is our deployment plan. We've got all of the tickets. We're going to work through these in order. Let's go ahead and create a separate chat. So what I would normally do is create a new conversation. So if we go up here to the project, we can click here to start a new chat. And then we're going to say, can you start working on this ticket and paste in the ticket number? And then we're going to work through that ticket. So you can see here now, we're going to fetch this ticket from Linear. And we're going to read the ticket and then start working on the change. So this is a fresh context window for the agent. And hopefully now it's going to go and work through and configure everything for us. So you can see the beauty of this is that the AI agent is now basically doing all of the work for us. As long as you've done a good planning session, as long as you're clear about what services you want to use and you're very clear in your planning, AI agents can basically just do all of the work for you when it comes to setup. And this would take me maybe a couple of hours to do manually. There's so many things to consider. There are so many mistakes you can make when you're doing this manually. I found it so much easier to use AI agents to help me here. Obviously, you could also use things like Terraform here as well. But again, writing Terraform is incredibly time consuming. It takes many, many hours. And what you can do is you can actually go ahead and provision your application, get it into a healthy state, and then write the Terraform from the actual production state. Again, you can use AI agents to help you write Terraform if you want to. If you want to go down that route, you can definitely do that. So one of the interesting things to kind of quickly point out, which is really important when you think about things like this, when the AI agent is creating the Cloud SQL instance, I don't know whether I specified clearly enough the size of this SQL instance. And so this is quite an expensive resource. And so this is where you might want to go back and forth with the agent in terms of figuring out the pricing of your application. You can ask for an estimate of the cost of your infrastructure and then ask the AI agent to help you make a decision about what size of database. So because this is a relatively trivial application in terms of data storage, all we're doing is storing documents in a database. There's a small number of them, so we can probably get away with the smallest SQL instance, which will be a lot cheaper. So these are the kind of decisions that you need to make as the human. The AI agent will do the work for you, but you still need to make that judgment call about what particular database to use. All right, perfect. So you can see that now the database is being created. Again, I did make a mistake when I made the plan. So we're using PostgreSQL 16. I believe the latest is 18. So this is the kind of detail that you want to pay attention to when it comes to the planning stage. And this is why it's so important to write a plan, because the AI agent is now making an assumption about the version of PostgreSQL to use that is actually probably not my preference. So I would have rather gone with a newer version of PostgreSQL. I'm going to leave it for this demo, but it's kind of an important point to think about. And it's one of the reasons why you want to carefully review the plan before the agent starts executing. One of the other benefits, though, of using agents is now it's very easy. If you wanted to tear this down, recreate it with PostgreSQL 17 or 18, the agent will just go and do that work for you. Again, this would be very time consuming, extremely frustrating for a human to have to do this kind of work. But an AI agent will happily sit there for 20 minutes, 30 minutes to go and do that work for you. So another good reason why AI agents are so valuable with this kind of work is The Cloud SQL provisioning is a time-consuming operation. If you're a human sitting here for 30, 40 minutes to wait for this to be provisioned, it would be incredibly frustrating. But the AI agent is quite happy to sit here for maybe 20, 30 minutes. It can poll the database instance, and once it's up and ready, it will continue on with the rest of the work. So this is a really good way to avoid this kind of tedious work within your day-to-day as a software developer. This is a really good example of the kind of task where I think Codex is a good fit. Codex is really good at long-running tasks, and these can be incredibly frustrating. These tasks can go on for 30 or 40 minutes. You can quite happily give this task to Codex, go off and do other things, and it will just sit here and work through the whole thing for you. It has no issues with these long-running tasks. One of the great things about using these tools for this kind of work is anytime you start to hit an issue, or you're not sure how to proceed, or you don't know how to do something, you can go and ask Codex to help you. This is such a valuable thing. Okay, because this is taking a while, I asked Codex if we could break down the work into parallel phases to speed this up, because we're waiting a long time on that database provisioning. Let's see if we can do something else while we're waiting. So it sounds like we can start this ticket. So I've asked it to kick off the ticket. So if you now look at our linear task board, you can see we have 2 of the tasks running in progress. So these are the 2 tasks that the agent is working through. In theory, we could have multiple tasks also running at the same time. There are always points when I'm using these agents that I sometimes just can't believe how much work they're doing and how powerful these things are. The number of tasks and operations and decisions that these agents are making still blows my mind after using them for so long. This kind of work historically has just been such a nightmare. So seeing AI agents run through all of these commands for 20, 30 minutes is just still mind-blowing to me. Okay, so at this stage, we've got kind of the general structure of everything. We're starting to provision all of the resources. We're getting everything set up. We have a very clear plan. So what I'm going to do, just in the interest of time, is ask Codex to just work through all of these tickets and get everything set up and done. Sometimes you might want to take more time to just verify things as you go through. But given this is quite a time-consuming process, I'm just going to ask Codex to get everything else done. So now we have the front-end web application deployed. We should, in theory, be able to go and hit this and see what it looks like. I don't know if this is actually going to work because we haven't finished, but let's take a look. It looks like this is now live. So this is running on Cloud Run. So we've successfully deployed the application, but the agents are still running. So they obviously have some additional work to do. I'm not sure if this is actually hooked up correctly, so we can go ahead and try it out just to see. So we're asking a question, can I return a laptop after opening it? It seems to be doing something, and it seems to be returning the correct answer. So it actually looks like the application is now up and running and fully functional. So I'm guessing a lot of what the agent is doing now is cleanup work and additional checks. So now that we have our application up and running, everything seems to be working. There are a couple of things we could use AI agents for at this stage. The first one is to improve our operational posture, adding dashboards and things like that. The other one that we could do is set up CI/CD infrastructure. So the idea here is that currently, if we want to deploy our application, we have to run a CLI command or do a manual operation. But what we could do is use AI or use the agent to configure this such that when you push your code to GitHub, it will get automatically deployed, which is probably what we want over the long run. So you could actually use an AI agent to do that for you as well. One more use case for AI agents that I just want to show you. There are so many things you can do here if you start to get creative, but let's see if we can build an architecture diagram from our live production system. This kind of thing is just so useful. So let's go ahead and go back to Codex. Let's create a new conversation and see if we can do this. So can you, based on the production infrastructure, create a mermaid architecture diagram in the README file that I can view and check out? So just jumping around a bit, it looks like the agent has completed the architecture diagram. So let's go into Visual Studio Code. Let's take a look at what it's done. So if we click up here, you can see a markdown preview. I'm just going to close out this one. So I was unable to visualize this in VS Code, but you can see here we've written a README file and we've added an architecture diagram here. So this kind of stuff is so useful. So even if you're trying to understand how your application works or you want to visualize something within your system, you can just get AI agents to read your infrastructure, figure out how things are connected. So you can see here we have a customer support user. They talk to the UI, that talks to the API, which then talks to the database. And we have Anthropic Vertex AI for the inference. And then you can see here, this is the scheduled job. So basically, whenever a customer updates one of these buckets, they put new documentation in there. This Cloud Run job will run periodically and then add that data or update the data in the database. And so whenever the customer is asking a question, it's always using the latest documentation from this repository. So you can see here now we have a new dashboard called Support RAG Operational Dashboard. Let's see what the agent came up with. This looks really nice. So we have API availability, the web traffic, the number of requests per second. You can see here just a bunch of information, and then also scheduled ingest job failures. So this is the thing we asked about that would be so useful. If we're running any kind of system like this in production, you definitely want to be paying attention to those failures. So this is great. We did nothing and we had a really nice looking dashboard. Obviously, then you could go back to the agent and ask the agent to customize various things about this. But again, I just absolutely love using AI agents for all of these things. This is the kind of work that would take so much time for a human to do, but agents can just blitz through it in seconds. If you enjoyed the video, please remember to like and subscribe. It means a ton. Thanks again for watching. All of the resources are going to be in the description below, and I'll catch you in the next one.